never show my children any videos.
That's right. I was there. I was there at that moment when he messed up for the 100th time. Okay, now remember the absolutely incredibly humorous story, the one that made you laugh deeply inside instead of externally, about the focus is where the sun's rays meet. And so so sun being just an object that is so far away that as the light comes in, it's basically coming in parallel to the axis. So whether it's a mirror or a lens, so if that is a mirror, and typically the mirror is, if I'm drawing it up, the mirror is just basically like an arc, whereas the lens would have two sides to it.
Unless it's thin lens, it's a straight line.
You can represent it as a straight line. If I were actually drawing the lens as a, I could also draw that as a straight line too, but yeah, you're right. I flip back and forth.
Are we doing a quiz on that then?
Yeah.
All right.
Yeah. I started out with any questions, and he had a question, so we'll do that first. And potentially find a marker that works well. So anything that's coming in straight like this is going to hit the mirror and then go through the focus. Or if it's a lens,
And by focus, that's the focal point.
yes.
Okay.
As long as they all end up with the lens. And do these prices belong to anyone? I'm going to assume that.
So a mirror is going to be a single line, a lens is going to be two lines.
Yeah, when I'm putting some curve to it, as opposed to just doing the quick and dirty straight line.
Okay.
Now, the focal point on the mirror is going to be basically on the same side as the opening. So if it's curved like that, the focal point is going to be, say, there. So that's going to then cut through that point. Whereas for a lens, the focal point that's going to hit
In the back.
On the other end of the.
in theory, on the other side. Now, I guess I should be more specific on that one. For positive focal lengths. So, yeah, because mirrors basically are designed to bounce light off, and so if it's going to converge, then it's going to go to the focal point. That's probably more accurate wording. Now, if I've got if I have a diverging mirror, the light that's coming in straight, obviously it's not going to bounce through the focal point. Matter of fact, it's going to hit the mirror and it's going to bounce away. It's going to bounce away from the focal point. And for a diverging lens, the focal point is here. Light's coming in. Since a diverging lens causes things to move away from the axis, it's going to move away from the focal point. That's supposed to be a straight line there. And as I step back, that looks better to me. All right, so that's one of the points right there. Another, you really only need two lines, although there's rules for three. The other one is if it hits smack dead center, it's going to do sort of what I think your gut feeling is. If on a mirror, if it hits the center, it's going to bounce back at the exact same angle. Angle of incidence is the angle of reflection, which is true everywhere, but at the middle, I think it's a lot clearer that it's doing that. And for a lens, if it goes through the center, it just
Carries on its way.
Yep, and that's. And so, as long as you can figure out where the intersection is occurring, so these obviously intersect right there, that's where the image is. It's a real image because the light rays actually do meet at that spot. Over here, I have light rays that actually meet at that spot. It's another real image.
The anywhere they meet, it's a real image.
Yes,
Okay.
So,
But-
but wouldn't one be, inverted? The image?
not that we have drawn it right here.
The one.
It's also possible I just misdrew it, and that's why it's looking like that.
The one to your right, it will be an inverted image,
That's an inverted image, definitely.
pointing down.
Yeah,
Okay.
So. the
that one, I just might have drawn it badly.
So the one on the left, or
That is not right. That's not right. I drew it badly. Right. So one on the right,
the one on the bottom left, that would be on the bottom left,
bottom,
on the, yeah.
This left.
Yeah, that one.
not this one. Okay.
That's a virtual, right?
That's gonna be a virtual image, so this one's gonna come in like this, and then the light's gonna bounce. And so the image, again, think about these light rays are coming into through your eye, hitting your brain. Sure, we'll go with that. I haven't had biology since ninth grade. And your brain's gonna process it, it's gonna follow those light rays back, and so we have these, the light rays don't actually meet, they're not penetrating the mirror, but it appears to our brain that it's right here. So that is it's a virtual image, because light rays don't actually meet at that spot. All right, now over here, let me see if I can draw this better, because Ronald was right. And despite my wanting to draw it the other way, I'm gonna draw it. This is a mirror. I'm gonna write down mirror. And I put a focal point there. So light that's coming in straight is then gonna bounce through that point right there. Light that comes, that hits the central point is then going to bounce back at that same angle. There we go. And the light rays meet over here. So it would be an inverted image over here. The reason why the other one was not it, and it was just a bad move on my part. This point right here involves light that's bounced off and light that's still going to it. Light's traveling in opposite directions there. So here, the light, both of these lights are coming away. Just like right here, both of these are coming away. It's not a look of a satisfied customer over there. I don't know.
No, we're good. I looked at my notes today and this week and I was like, it just doesn't make sense. Just looking at my notes, I need like
Okay.
worded explanation.
Yeah, there's two other lines we could draw, if you're interested.
Are they required for the quiz?
No, not
Okay.
necessarily.
I have a question about calculating the focal length. So the focal length is the reciprocal of the object plus the reciprocal of the image is equal to the reciprocal of the focal length?
Yeah, when you say object and image, that is the distance
image,
from
yeah.
basically from where the central axis hits whatever you're looking at
Right.
to where the object is the object, yes.
The length of the object to the axis is,
Yeah,
And what's our F, P, and Q on the graphs? Yeah, I know F is the distance from the lens or mirror to the focal point.
yes,
P is the distance from the object to the lens or mirror.
right.
And then Q is
What's left?
the image.
Yeah.
Image.
Image to
from
mirror.
the lens or mirror.
Yes.
Okay. Okay. That's the only one I could remember. I was just stuck on it.
But I'll leave that up there. I also, in some courses past, I've done d sub 0 or d sub o plus 1 over d sub I is equal to 1 over f for distance to object and distance to image.
But
I
we're
don't know if that
always,
helps you,
but it's always the distance from wherever the axis is, lens or mirror or whatever.
Yes.
Okay.
The only way that it would get more complicated than that is if I had multiple mirrors or multiple lenses, and then it's still to the axis where the mirror and the axis meet. It's just, you need to keep track of which one's which.
So on the test, we are given the focal length and the distance of the object. That's what we're getting, right?
That traditionally, that's what you're gonna get this
Okay.
morning.
Well, no, I'm getting that like on the test. That's what you're
You,
getting.
you have to be given
Something.
some information. I mean, I could give you the image and you have to figure out, and the focal length, and you have to figure out what the object is. I mean, it's the same, you plug it into here, it's just you're plugging in for Q instead of plugging in for P.
drawing this stuff?
Say it again?
Do you have any rulers for drawing this?
Uh,
So it can be at least somewhat straight.
Yeah, oh yeah, we got rulers.
Okay.
Or like a protractor.
Yeah, that one too. Something I can draw a straight line with. Or you're gonna get a line that was about like that.
Well, you know, I am very particular about lines being drawn straight.
Well, you know, being on the test now.
I appreciate your pulling out all the brakes, all the stops. Doing it right. All right, any other questions right now? I know there's a question on the lab, but I figured.
I'll do
I
that
could wait.
after the quiz.
I do have a question. Is there any, I'm trying to think how to word it, between a virtual and a real image, are there ones that it's always gonna be one or the other? Do you understand what I'm
I mean, as
Or
in,
can it- is it
is
always?
this mirror always gonna produce a real image, or is that what you're asking?
Yeah,
No, because I could stick, if it gets close enough, if it's within the focal length, things get funky. So,
And what's the formula for magnification? Or do we need to worry about that on the test?
It's negative Q over P, I believe.
Okay.
You're not gonna give the one with, n, parentheses, n minus one, parentheses.
the lens maker's formula?
Yeah,
Not for this,
okay.
not today.
Okay, I was just asking.
And the focal length, will the focal length always be positive? Or could it be negative?
No.
If
No.
it's negative, it'll be on the other side, won't it?
This has a positive focal length.
Mhm.
If the causing of the light to come together, it's a positive focal length. If it causes the light to diverge,
Is,
such as a convex mirror or concave lens, then it's a negative focal length.
Okay.
so a concave lens has a negative focal?
Yes, a diverging lens, which are typically
Oh,
shaped like that.
diverging lens.
I guess we're gonna be given that, so.
I would tell you, I would,
Maybe.
Maybe.
if I said it's a diverging lens and the distance from the
It's gonna be
from the
negative.
lens to the focal point is X centimeters, then, you know, translate that in, oh, focal length is negative.
Mm.
I'm gonna try my best. A lot of information in 8 weeks.
Not as much as the next 8-week group is gonna get.
This
Oh,
class
sure.
is too short.
So, part of this was an experiment on my part to see how much I could get done without doing the, hey, watch these videos before you come to class. And, so,
Test though.
we all do the best we can with whatever we have at that moment.
Yeah. I've learned. It's all that matters.
At least I learned something.
All right. I'm not gonna, take out a piece of paper. If you need paper, I can hand some to you. But I'm gonna write it up on the board.
Oh, we need a piece of paper.
Yeah.
Okay.
Anyone need paper?
Yes.
Thank you.
Okay, thank you.
All right.
Which chapters are these?
How does 34 through 37 sound? I don't know.
Yeah, close enough.
I will look at the work and I will go, oh, yeah, I know generally what this is. All right. Do you have a? Oh, probably don't need to film this. So when you show your kids these videos later,